Hi guys, how are you? Today I'm going to solve this question related to electric potential energy. First read the question. An alpha particle with kinetic energy equal to 11 mega electron volt is directed to a lead nucleus. How close will it get before the alpha particle is completely stopped? Right. An alpha particle is moving towards a lead nucleus. Initially, alpha particle has kinetic energy of 11 mega electron volts. So according to the question, the alpha particle comes to rest. So when the alpha particle comes to rest, we need to find the gap between alpha particle and the lead nucleus. So basically, we got to find the distance between alpha particle and the lead nucleus. Right. Let's try to understand what are the key information given to us. First, we'll draw a rough diagram, a sketch. So this is what I usually do. I try to figure out what happens here. Alpha particle moves towards the lead nucleus because it has kinetic energy. Alpha particle is positively charged. Lead nucleus is obviously positively charged. So the lead nucleus exerts a force on alpha particle towards the opposite direction. So it opposes the motion of alpha. So therefore, alpha has to do work against the electric field of lead nucleus. So therefore, the kinetic energy of alpha particle is reduced. So now what happens to this kinetic energy of alpha particle? So I have this question. Right. Now the first thing that we need to do is, when it comes to any physics question, we need to identify the approach. How can we identify the approach? It is based on what we are supposed to find. So in this case, we are supposed to find the distance between alpha particle and the lead nucleus. And the approach mainly depends on the information we have. So what are the information we have? Let's see what are the information we have. We have the initial kinetic energy of alpha particle, that is 11 mega electron volts. So let's write it down, right? Kinetic energy of alpha particle. Initial kinetic energy of alpha particle is 11 mega electron volts. So this is what we have right now. With this information, we got to find the distance between alpha particle and the lead nucleus at the end, when the alpha particle comes to rest. Okay. Now, we can start with kinetic energy, but how can we get at our final destination? Right. So that is where we need to plan properly. Otherwise, if we do not have a proper plan, we might get stuck at the middle. So therefore, you got to have a plan before you start with the question. So this plan should be in your mind. If you can't do it mentally, what you should do is, you can just make a rough sketch as to what you're supposed to do. So that's what I'm going to do here. You start with kinetic energy. Now what is happening to the kinetic energy? Kinetic energy can be converted. What type of energy? When it comes to electric field, as we know, electric field has electric potential. So then kinetic energy of alpha particle can be converted to potential energy. Right? So then let's write down the equation for potential energy. that is kq over r. All right, now we can understand. So when it comes to potential energy, there is a component uh, with r. So potential energy is included. The equation of the potential energy is included with distance. So now our final answer should be also the distance, right? So now we have found a way to do this. That is, we can assume the kinetic energy of alpha particle has been converted to potential energy, right? If the alpha particle comes to rest, that means the potential energy is kinetic energy of the alpha particle has been totally converted to potential energy. That is why the velocity becomes zero, right? Now to do this, we need to identify the correct equations. First we identify the approach, the second thing is the theory part, right? Now the logical part is completed. We know what to do, we know the flow, right? So that is the most difficult part. But then when you know what you're supposed to do, you can figure out what are the equations you need. And then we are dealing with charges, that is alpha particle and the lead nucleus. So you need to know the charge of alpha particle, right? Alpha particle has 2 protons and 2 neutrons. So therefore, charge of the alpha particle is +2 into 1.6 into 10 to the power minus 19 coulombs. And the lead nucleus has 82 protons. So the atomic number of lead is 82. So therefore, charge of lead nucleus would be 82 into 1.6 into 10 to the power minus 19 coulombs, right? Then our kinetic energy is given in terms of mega electron volts. So electron volts. Now we need to know what is meant by electron volts. Electron volt. Electron volt is defined as the kinetic energy gained by an electron when it accelerated through a potential difference of 1 volt. Right. So this is the electron volt. Electron volt one electron volt would be equal to 1.6 into 10 to the power minus 19 joules. So that is our conversion, right? So you need that conversion as well, because we got to convert mega electron volts into joules, right? Now we have figured out what are the equations we are going to use and what are the values we are supposed to know. Now we can do this question, because we have a clear way of starting the question now, because we have a clear idea. Our flow is now perfectly in our mind, right? So let's start the question. How are we going to start the question? So we'll start with this equation. Kinetic energy of alpha particle is equal to potential energy of alpha particle, right? Kinetic energy of alpha particle 11 mega electron volts. Potential energy of alpha particle. How do we find potential energy of alpha particle? First we need to know the potential due to alpha particle. 4 pi epsilon naught 1 over 4 pi epsilon naught q. So we are using this equation here, right? This equation. What is Q? This potential is created by lead nucleus because alpha particle is in the electric field of lead nucleus. So what is the charge of lead nucleus? That is 82 into 1.6 into 10 to the power minus 19 coulombs divided by the distance between lead nucleus and the alpha particle. So that's what we need to find. So that's unknown, right? So this is the potential. Now how can we convert potential into potential energy? So there we need another equation. That is energy or work done is equal to charge into voltage, potential difference or potential, right? Now the charge of alpha particle, 2 into 1.6 into 10 to the power minus 19 coulomb, right? Now we'll convert 11 mega electron volts to joules. Since it's mega, it has to be 10 to the power 6 electron volts. So 1.6 into 10 to the power minus 19. So 1 over 4 pi epsilon naught, which is the Coulomb's constant, that is 8.99 into 10 to the power 9 into 82 into 1.6 into 10 to the power minus 19 into 2 into 1.6 into 10 to the power minus 19. This whole thing divided by R. Right. So the only unknown variable in the equation is R. So you are able to find R now.